In this video, we're going to go through these topics: coordinate geometry, linear law, trigonometric functions, simple trigonometric identities and equations, R formula, as a revision package for the end of the year exam for the secondary 3A math syllabus. Right, if you look at these questions, the two main concepts are when two lines are parallel to each other, they have the same gradient. If two lines are perpendicular to each other, m1 times m2 equals to -1. So let's look at part 1 first. Right, because the line AD is parallel to the line BC, hence they have the same gradient. So we can find the gradients of BC using y2 minus y1 over x2 minus x1. And that will give you the gradient of AD. Right, and to find the equations of AD, you can make use of this formula here. Right, you sub in the gradient to be 3/5, and then you have to sub in one point, which is x1, y1. So the particular point must lie on the line AD. So if you look at the line AD, that's only one point that happens to be on the line AD. And that's the only one point that you can use. So you substitute into this formula here, right, to simplify it, and you will get the equations of AD. Alright, so the next thing is to find the equations of CD. So if you look at the line CD, right, it is perpendicular to the line AC. So in other words, you can actually apply this concept here, which is m1 times m2 equals to -1. m1 is the gradient of DC, m2 is the gradient of AC, or vice versa. Okay, both gradients multiply gives you -1. So if you look at this diagram here, obviously we can find the gradients of AC because you have 2 points there. You have 2 points on the line AC, so you can find the gradients of AC. Right, and hence the gradient of DC will be -1 divided by the gradient of AC. And you apply the same concept, substitute into the equations. Right, and you use point C because point C is the only point that lies on the line DC. So that is part 1. Alright, so part 2, if you observe carefully, D is actually the intersection point of the line AD and DC. So basically, you just have to solve these two equations simultaneously. Right, so point D will be 8, 10. Alright, let's come to part 3. Part 3, to show a triangle ACD is isosceles, the concept involved here is just to show that any two sides are equal in length. So sometimes you just look at the diagram and then you estimate which two sides have roughly the same length. So if you look at this diagram here, it will be AC and DC. Well, however, if you find that AC and DC don't equal to each other, then you have to go on to find the third length, which is AD. So the concept here is just to use the distance formula, find two lengths that are equal to each other, and you prove that triangle ACD is isosceles. Alright, so I would advise you to leave your answer insert because that is exact form. And it's exact form, so it's good for comparison. Here we're applying this rule here. Right, and square root 4 is 2. Do the same for AC, and you realize that both of them have the same length, which is 2 square root 17. Right, so from there you can conclude that ACD is isosceles. Right, let's look at the next questions. You're asked to find the equations of B. Find the coordinates of B. So again, if you look at coordinates of B, look at this point B here. B basically is the intersection point of AB and BC. So that gives you an idea that you have to find the equations of AB, find equations of BC. But equations of BC is given to you, right? So you just have to find the equations of AB. So what's the purpose of equations of BC? Yes, if you look at here, your AB is actually perpendicular to BC. There's a 90 degrees here. So which means your AB is perpendicular to BC. Hence, you can apply the concept M1 times M2 equals to negative 1. So therefore, we have to make use of your equations of BC to find the gradient. Right, write it in the form y equals to mx plus c. So in this case here, your gradient will be negative 3 over 2. Hence, the gradient of AB will be negative 1 divided by negative 3 over 2 gives you 2/3. Right, use the concept that we have applied earlier on in the earlier questions. Right, so here we have to substitute point A because obviously there's only one point on the line AB and that's point A. Right, so we found the equations of AB, solve it simultaneously with equations of BC. Alright, so we found B to be 7, 12. Right, so the next part is a bit tricky. You're given that M is the midpoint of AC. Alright, so we have a point M which is the midpoint of AC. But before that, wait, hang on, we need to find the point C first. So, but because C lies on the line BC, right, so we just can substitute y coordinates to be 0. Any points that lies on the x-axis will have y coordinate 0. So you substitute y equals to 0 into your equations of BC, into this guy here. And then you'll find that x is equals to 15. Hence, the coordinates for point C will be 15, 0. All right, next step, we have a midpoint here, M on AC. Right, so we can apply the midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. And you will find that M is 6.5 and 3. All right, so what happened is that you need to extend another point D, such that ABCD it's a rectangle. All right, so we're going to let point D be A, B. So what's the concept involved here? The concept involved here is that for certain quadrilaterals, the midpoint of the diagonals will be the same. So this is a special case, the rectangle. So the midpoint for the midpoint of AC, which is indicated there to be M, this midpoint will be the same for the midpoint of your diagonal BD. Right, so we already found the coordinates of B, which is 7, 12. Right, so we apply the midpoint formula again, which is 7 plus A divided by 2 gives you the x coordinate of your point M, which is 6.5. You do some manipulation, you get A equals to 6. Likewise, 12 plus B divided by 2 gives you the y coordinates of point M, which is negative 6. Right, so from there you found D to be 6, negative 6. So here the concept involved is, there are two concepts involved here. The midpoint formula and also the midpoint of the diagonals of a rectangle are the same. Right, beside rectangle, what other quadrilaterals have the same concept? Basically, they are square. If it's a square, if it's a rhombus, if it's a parallelogram, the diagonals of the midpoints will be the same. So you can use this midpoint formula. Right, these questions involve the concepts of linear law. So let's start off by writing down the general form of a linear line, which is y equals to mx plus c. Okay, capital Y, capital X. Right, so if you look at the diagram on the y-axis, it's x over y. This is x over y on the y-axis. And on the x-axis, it's 1 over x. So if you were to substitute all this data into your y equals to mx plus c, this is what you'll get. All right, we're going to call it equation 1. All right, so there are two unknowns there. Basically, you have the gradients and you also have the y-intercept. You can't find the gradient. Why can't find the gradient? Because b is unknown. So your gradient will have a unknowns there. Right. And if you can't find m, then obviously you can't find c. So we can't actually use equation 1. So we have to go back to use instead this equation that's given to you. All right. So you need to know which information to make use of. All right. So from what we're given there, x squared minus 2xy plus ay equals to 0, we need to manipulate it. Right. That means to do some algebraic manipulations to get our equation 1. Right. So basically, I'm going to divide every term by xy. Right. And then rearrange it. Okay. So you will discover that it's very similar to equation 1. Okay. If you were to compare it with equation 1 here. Okay. Oh, we can pull out the negative a first to make it clearer a bit. Right. So in this case here, it's very clear already that your gradient is actually the value for negative a, and the y-intercept value is 2. Right. So from there, how are we going to make use of it? Yes, we can find your gradient first by substituting in 1 point, because you have a point 2,7 there. So you can sub in that to find the unknown a. Okay, which found your a to be negative 2.5. And once you found the values of a, which is 2.5, you can just use your gradient formula to find the values of b. All right, so the concept here is that linear form is have to conform to y equals to mx plus c. Make sure it's capital Y, capital X. Then from the graph, fit in what is the values on the y-axis, what's the variable on the y-axis, what's the variable on the x-axis. And then use the gradient formula. So you have to know how to make use of the information given in the questions. Okay, like in this case here, that's to if you look at equation 1, right, you can't find gradient, you can't find y-intercept because there's so many things that it's not given to you. Then you have to fall back to go back and look at the questions and fall back to this information that's given to you that's highlighted in blue. Right, let's look at the next question. This one is slightly easier. Right, again, same thing. Let's start off with y equals to mx plus c. So if you look at the diagram, on the y-axis is xy, and on the x-axis is x plus y. So you just plug into this guy here, y equals to mx plus c. Right, so you're given 2 points there. So this question is easier than the previous one. You can just easily use the 2 points to find your gradient, which is 3 over negative 2. Plug into your equation 1. And also sub. You can use 2,6 or 4,3 up to you to find the unknown c. Right, so after finding all these things, again, plug it back into equation 1, which will be xy equals to negative 3 over 2 bracket x plus y plus 9. Right, so we need to, here I usually like to convert any fractions to a non-fraction. So I'm just going to multiply by 2 throughout to get 2xy equals to negative 3. Negative 3 over 2 times 2 basically just give you negative 3 times bracket x plus y. 9 times 2 is 18. Right. Again, do some manipulations. Open up the bracket. Group all your y terms on the left hand side because you're supposed to make y the subject. So you have to group all terms involving y together and then factorize it. And then make y the subject. And that's it. That's the answer. Right, so we have done questions involving coordinate geometry, involving linear law. All right, let's attempt to do some questions on the chapter of trigonometry. Okay, if you look at the questions, this one, it's if you have such a question, it's a bonus. Why is it a bonus? Because beta, right, this guy, it's pronounced as beta. It's an acute angle. So acute angle, what does it mean to you, acute angle? So acute angle basically is an angle that's between 0 to 90, and that happens to be in the first quadrant. Right, so let's draw a right angle triangle in the first quadrant. All right, so basically trigo ratios are just trigo ratios. Yeah, trigo ratios. So sine beta is equals to P. So to find sine beta, it's taking the sides of the opposite divide by hypo. OH, so right, SOH, O over H. Right, so in this case here, you rewrite P as P over 1. So you label your opposite side as P, label your hypo as 1. Then how do I get this guy here? Okay, you will have to use Pythagoras theorem. Alright, so B is equals to square root A squared plus B squared, which is just 1. Sorry, we're finding, yeah, correct, is equals to C squared. Sorry, B is equals to square root of C squared minus A squared. So your value of C, it's 1. So it's 1 squared, which is 1 minus P squared. So that's how I get square root 1 minus P squared for your adjacent. Alright, so to find tangent beta is the ratio of opposite sides over adjacent sides. O over A, P over square root 1 minus P squared. Alright, so for part 2, you will have to use the addition formula. So for trigonometry, it's best to memorize all the formula. If not, you must get ready, write down all the formulas and keep referring to it. Right, so basically you cannot just apply your own thinking. This is not equals to sine 90 minus sine beta. Okay, this is a no. Right, so you have to use your addition formula. Okay, so sine 90, if you use a calculator, or if you by now you should have remembered it to be sine 90 to be 1. If you cannot remember for memory, just use a calculator lah. So sine 90 is 1, cosine 90 is 0, and you end up getting cosine beta. So cosine beta is the ratio for adjacent side over hypo. Okay, which is square root 1 minus P squared over 1, which is just 1 square root 1 minus P squared. So do the same for part 3. Apply the addition formula. Get negative sine beta, which is just negative P. So this is a bonus question if you happen to see this in your exam. Alright, this question is slightly harder than the previous one. It's not so bonus because because what you're given is not in the first quadrant. The angle A is actually between 180 to 270, and that happens in the third quadrant. And anything that happens in the second, third, fourth needs more attention when you label the length on the x-axis or the length on the y-axis. Okay, what do I mean? First of all, let's draw a triangle in the third quadrant first. Oh, okay. Let's try to express tangent A as the ratio of the opposite side over the adjacent side. Tangent is TOA. Okay, that's why it's O over A. Let's draw a triangle. Okay, in case you don't know how to draw this triangle, right? It's quite easy to remember it this way. You just, I don't know, you call it a ribbon, a bow tie, whatever. Okay, right. So this will be all your angle alpha. Okay, so in the third quadrant, that is where your angle A is. Alright, so why do I label this guy as negative 4? You see, here it's a positive 4. Then why am I so busybody to label it as a negative 4? Yes, I'm not busybody. You label it as negative 4 because this guy here, it's on the left-hand side of the x and y axis. You see, when you label the x and y axis, right, do you recall that all these guys are positive value? All these guys are positive, but here it will be negative. Here also negative. Okay, so because we're dealing with this side here, which is negative side. That's why you have to put the negative in front of your 4. So likewise for 3, alright, it's below the x-axis. That's why you need to have a negative here. So that's the reason. Okay, and then to find the hypo is basically the radius of the circle. So hypo is always positive because you don't get a negative value for radius of a circle, right? So therefore, the hypo, you don't have to worry. It's always a positive value. So in this case here is using Pythagoras theorem is 5. Okay, so part 1. All right, part 1, recall. Look at the third letter, C. So what does it mean? It's your reciprocal ratio, 1 over cos A. And I give you 1 divided by cos A. So cos A is the trigonometric ratio for car, A over H. Negative 4 over 5. Right, so 1 divided by negative 4 over 5 gives you negative 5 over 4. Okay, part 2, as usual, you use your addition formula. Okay, use addition formula. Part 3 also use addition formula. 0 minus A is just basically minus A. Right, so cosine 0, cosine A plus sine 0, sine A. Right, so cosine 0 is 1, sine 0 is 0. So you end up having cosine A. And you get negative 4/5. Right. Alright, so we have done some questions on trigo ratio. Let's try to do some curve sketching. Right, for part 1, you're asked to find the values of A. So the A is actually the amplitude. And to find amplitude is highest y coordinate minus lowest y coordinate divided by 2. So that gives you, if you look at the diagram carefully, this is our maximum point and the highest y coordinate is 1. This is our minimum point. Your lowest y coordinate is negative 3. So it's just 1 minus 3 divided by 2 gives you 2. Okay, I need to warn you guys a bit. Amplitude is always a positive value, so amplitude is equals to 2 if I ask to find amplitude. However, the values of A need not be a positive value. It can be a negative value depending on the shape of your curve. Here what you're given is an upright sine curve, upright. Okay, so therefore A is positive. If you are given like this, okay, an inverted sine curve, then your A will be negative 2. Okay, you have to take note of this. Otherwise, you will lose your 1 mark and you say I never teach properly. Okay, right. But if you're just finding amplitude, then bear in mind it's always a positive value. Okay, so one cycle is between 0 degrees and 120. That's why I highlighted it for you, the one in blue. And therefore, the period is 120. And another way of finding period is 360 divided by B. B is the coefficients of X. So 360 divided by B gives you 120. Do some cross multiply here and there, you get B equals to 3. Then how do you find part 3? Right, so basically you can just use the maximum or the minimum point. Okay, I'm going to erase this one here because I need the space to do part 3, yes. So I use the maximum point instead. Oh, sorry, I use minimum. Yeah, I use the minimum point, which is 0 degrees negative 1. I use this guy here. Alright, so I use this guy here to sub inside this equation. Because you already found the values of A, you can just put it in. You already found the values of B, which is 3, you can just plug it in. Then substitute y to be negative 1, substitute your x to be 0. 3 times 0 is 0, sine 0 is 0, therefore you get C equals to negative 1. Okay, let's do another question. So for part 1, yes, amplitude. So we know amplitude is always positive, so that's don't need to worry too much about it. We just compare your given curve with y equals to a cos bx plus c. So a is your amplitude, which in this case here is equals to 3. Okay. Oh, okay, yeah, that's it. Right. Okay, I put a modular sign there because what I mentioned earlier on, your A can be a negative value. If you're given the inverted curve, then it's a negative value. But because amplitude is always a positive value, so we would want to modulus it. So that 2 vertical lines basically just to convert any negative number into a positive number. So if your A is a negative value, you just put the 2 lines there and then miracle will happen. You'll become a positive value for amplitude, because, let me repeat again, amplitude is a positive value, but A can be negative or positive depending on the shape of the curve given. Okay, so amplitude is 3. Then how do you find periods? Yes, period is 360 divided by B. In this case here, your B is 4. B is the coefficients of X. So 360 divided by 4 is 90. So that means from 0 to 90 is one cycle. That's what you mean by the period. Okay, 0 to 90 is one cycle. Alright, so let's look at part 2. Okay, so this is something you need to remember. Okay, the maximum value for cos bx. B can be anything, can be cos 2x, cos negative x, or cos whatever x. The value is between negative 1 to 1. So hence cos 4x will be between negative 1 to 1. And if you multiply by 3, it will be between negative 3 to 3. And if you add a 2, it will be between negative 1 to 5. So the maximum values for your y will be 5. The minimum value will be negative 1. So what does this mean? It means that if you're going to draw your curve, okay, some of you may not understand what it means. It means draw the curve, then your maximum y value is 5. Your minimum y value is 1. So your curve could be something like that. I don't know. Later we will draw the curve and see. Okay, this is what it means. Okay, let's erase it, erase it, erase it, erase it, because we need the space. Okay, so that is what it means by the range of values of y. Maximum y coordinate is 5, minimum y coordinate is negative 1. Okay, so that's part 2. So part 3, how do I go about solving it? Okay, I think for part 3 is, I was trying to think whether I should just sketch the curve for you, but I think the easier way is just to solve the trigo equation lah. So if your y is 5, that's the maximum value of y, right? Then you will get cos 4x equals to 1. So that is a trigo equation. So how do you solve trigo equation? Yes, find alpha. Alpha, make alpha your good friend. So alpha will be cosine inverse 1, which is 0 degrees. So for cosine to be positive, you see this guy is positive. If you look at the ASTC, cosine positive will be first in the fourth quadrant. So first quadrant is 0 degrees. Fourth quadrant is 360 degrees. Divide by 4, give you 0.90. So likewise, do it when your y is the negative minimum. When y is negative 1, you will get cos 4x equals to negative 1. Alpha is still the same, cosine inverse 1. Alpha is a positive, it's a cube angle, so always trigo inverse positive value. Right, so even though you see a negative guy here, you still cosine inverse positive to find your alpha. Then this guy here will tell you which quadrant. This guy will tell you that it must be second or third. So second quadrant is 180 minus 0, which is 180. Third quadrant is 180 plus 0, so 180. So how do I explain this one? Okay, there's an explanation there. Right, because the range given is from 0 to 180, but you're not dealing with x. Okay, AMAth is a bit not so straightforward lah. They don't make your life so easy for you. Alright, you're not dealing with x, you're dealing with 4x. So the new range will be between 0 to 720. Okay, hence you need to go round the circle one more time, go around the world one more time. So you take 180 plus 360, one round is one unit circle, so which is 360. So that's how you end up getting two answers for x. Okay, so what are the minimum, what are the maximum points? So basically from there you can just tell already. Maximum point will just be 0 degrees 5, 90 degrees 5, and minimum point will be just 45 degrees negative 1 and 135 degrees negative 1. Yes, that's it. Alright, let's look at another question on curve sketching. I think it will be the last one. Okay, so given fx is equal to a plus 3 sine bx. Alright, so if you look at the how the questions are being arranged, alright, they're not similar in nature to each one another. Okay, if you were to recall, the first questions we did was like I cannot remember. Anyway, you just go back and look at all these previous questions, you'll realize they're not so similar in nature, meaning they don't ask the same thing, right? But the concepts involved are the same. You must know that the period for sine and cosine is 360 degrees over b. B is the coefficients of x. And then you must understand how to go about finding amplitude. You must understand the meaning of maximum and minimum values of fx and the corresponding angles to give you maximum minimum value. So these are the three major concepts that you need to understand. Then you can apply to any questions. Right, so let's look at this. Okay, amplitude is easy. Basically, it's just the values of A. In this case here is 3. Right. Part 1, that's very easy. Easy mark for 1 mark. Okay, part 2 is slightly harder. Find the values of A and B. Okay, so this is what I mean by the concept just now I mentioned. Maximum minimum value for sine bx is between 1 and -1. For cos bx also is between 1 and -1. So what are the angles that gives you sine bx equals -1? So you need to know the shape of a curve well. So sine 270 gives you -1. Sine 90 gives you 1. Okay, so you're given that the minimum value of fx is -1. So I used sine bx to be -1. Minimum value means the minimum point. Refer to the minimum point. Minimum value is not equals to minimum point, sorry. Minimum value refers to minimum point. In here, we are using this guy here for minimum value. If you are finding maximum value, then you use this. So you sub into your equation. So sine bx will be -1. So a plus 3 times -1 gives you -1, minimum -1. A is 2. Okay, easy peasy to find A. Then to find B, use the period, yes. So the coefficients of x given here is capital B. So there'll be 360 divided by B, and your given period to be 120 here. So 360 degree divided by capital B equals to 120, and then from there you can find your B. Okay, so you found all your ABC, then what's the next thing? Yes, of course, to sketch the graph. So if you recall how I teach you to sketch a graph, you've already forgotten, refer to the earlier video on how to sketch a graph. So basically, you just divide your periods into 4 quadrants. Why 4 quadrants? Because the circle has 4 quadrants, first, second, third, fourth. So your period is 90 degrees. Sorry, wrong. Your period is 120. So you divide 120 into 4 quadrants, but you always start with 0 degrees first. Okay, you must always start with 0. So 30, 60, 90, 120. Okay, you plug all this angle inside your equation, inside this equation. Alright, then you just use a calculator. 2 plus 3 sine bracket 3 times 0. You will get 2. Sine 0 is 0. 0 times 3 is 0. 0 plus 2 is 2. So likewise, change your x to 30 and so on and so forth. Then you get all the values for your y. Then next thing, please use a ruler to draw your x and y axis. Label all your points correctly. Why do I do it until 180? I did it until 180 is because of the range given. Okay, one cycle is just from 0 to 120, but you don't stop at 120. You must always answer to the question asked. So they want you to continue to draw until 180. So you must answer to the question asked. Okay, so you continue the cycle, continue, and that's it. That's how your curve looks like. Beautiful curve. Okay, so we have done, let's do a recap: coordinate geometry, linear law, trigo ratio, trigo curves. Now we're going to do trigo proving. Alright, so if you look at this question here, okay, which sides do you think has more to work on? So obviously on the left hand side lah. But I think some of you will be very tempted, okay, to expand this, to use a minus b squared to expand this. Right, go ahead and do it. Yes, why do I say that? Then you will meet a dead block, or is it a dead block or dead road, whatever. You will get stuck, and then you realize, maybe I should not be using that method. Right, so just try. You have to try. For proving question, you just need to try. Okay, so if you realize that that's not the correct method, then you try again. You try this method I'm going to show you. So please try first. Okay, please try first. Yes, so some recall questions, all these things you must know already. You need it's just that you need all these equipments, before you can build a house, before you can construct something. So all these are the things that you must be already inside your head, inside long-term memory. So cosecant theta is 1 over sine theta, cotangent theta is cos theta over sine theta. So we start with the left-hand side. All right, convert it, convert it, convert it. Okay, don't be tempted to expand it, okay? If you want, just go ahead. Okay, I'm not going to do it. Combine them into a single fraction. Now you can break into two. Okay, I'll explain to you why I want to break into. Now it's a turn for you to expand it. Right. And then let's do another recall. This is your trigo identity. Okay, you've already forgotten it. You really have to memorize them. If you want to do well in the chapter of trigo, you have to memorize all this formula. You know, it's just like all this, it's just like a batch of all these tricks. So you know that when you can take out which tricks to use. Okay, so you replace sin squared theta with 1 minus cos squared theta, factorize the 1 minus cos squared theta, and then you can do some cancellation. This guy and this guy will give you 1, and then you get the answer, happiness. Yeah. Okay, so this is a relatively easier questions than the earlier one we have done. So again, let's do some recall. Secant theta. So if you look at the letter C, C is the first letter of the trigo ratio cosine. So secant theta is equals to 1 over cos theta. Right. So replace secant theta as 1 over cos theta, and then also write cos theta here as cos theta over 1. So you see that there are two fractions here combined into 1. Okay, that will give you 1 minus cos squared theta over cos theta. And 1 minus cos squared theta, let's do a second recap here. Yes, it's your trigo identity. Sin squared theta plus cos squared theta equals to 1, your trigo identity. So hence your sin squared theta will be 1 minus cos squared theta. Okay, so you can plug it in here. And then rewrite it, sin squared theta over cos theta, you can write it as sin theta over 1 times sin theta over cos theta. What's the purpose of doing it? The purpose of doing it is just to manipulate it to get the answer that we are asked to get. Okay? So sin theta over cos theta is equal to tangent theta. Alright, so this one is the most challenging of all the proving questions so far. Okay, yeah, we're going to start with the left-hand side, more things to work on. So there are two fractions there, so we just have to combine them into one single fraction, and there's nothing else much you can do, but just to combine them. Okay, and then you can expand this one. This you can use your a minus b squared. Give you a squared minus 2ab plus b squared. So just go ahead and expand it. But please do not expand the denominator. Usually we don't expand denominator because it can be simplified with the numerator. Okay, do some recall again. Your trigo identity. So we can replace 1 with sin squared x plus cos squared x, and then see what happened. Right. And then you can simplify further. Your cos squared x and your cos squared x will be gone. And then your sin squared x plus sin squared x will give you 2 sin squared x minus 2 sin x, and then you can factorize your negative 2 sin x. The purpose to factorize negative 2 sin x so that I can make these two guys the same, so that I can simplify further to just get negative 2 sin x over cos x, which is negative 2 tangent x. And that it gives you the right hand side. Right, so these questions that we're going to do next is rather tricky. Yes, rather tricky because it's not so straightforward like you're supposed to find x between 0 to 2 pi. You know, you're supposed to find x to be more than 12 radians. So that means your values of x can be like 12.1, 12.2, 12.3, 12.4, 12.5, so on and so forth. And then you find the least one. So the least one will be 12.1. Example. Okay. So it's a bit tricky. Why? Because you need to calculate how many rounds you need to add to your alpha. Okay. But step 1, you still have to find alpha lah. Okay. You still have to find your alpha, your good friend alpha. And then step 2 is to determine where, the new range. Yes, of course, the new range. So x is more than 12. And then since we are finding for 3x plus 2, then the new range will be 3x plus 2 more than 38 radians. So we only considered anything that is more than 38 radians. Anything less than 38 we're not interested in. All right, then the next thing, of course, is your ASTC. For tangent to be positive, this is a positive value. You will come from the first and the third quadrant. All right, but in this case, it's tricky because you just need to consider one of the quadrant. In this case here, you actually consider the first quadrant only. All right, why is that so? You can go on to find your third quadrant and then you realize that no, it doesn't give you the answers. It's because you're supposed to find the least value, you see. So if you consider the third quadrant, right, the answer that you'll be getting will be much more than 38. That would not give you the least value. So to get the least value, you consider the first quadrant. And then first quadrant will be 1.176 plus you have to go through, you have to count how many rounds, so that you will have more than 38. So in this case here, 12 pi is actually 6 rounds, it's not 5 rounds. Because 1 round is 2 pi, right? 1 unit circle is 2 pi. So 6 times 2 then give you 12 pi. So 1.176 plus 12 pi, if you use a calculator to work out, right, it's more than 38. I think it's 39 point something. All right, then you minus 2 divided by 3 will give you the least value of x to be 12.3. Okay, if you don't quite understand this one, you have to go look at the video a few times because this is a bit tricky. Then for part B, it's even more tricky. Why even more tricky? Because you are finding the largest value. So in this case here, you don't get the answer. All right, wait. We go on to find your alpha first. Okay, no, we go step by step. So finding alpha for cosine inverse 1 over square root 3, 0.9553. Second step, you find your new range as usual. So your 3x must be less than 12, and then ASTC. All right, so ASTC, so for cosine to be positive, it can be first and the fourth quadrant. So it's opposite from part A. Part A, to find the least value, you take the answer from the first quadrant, right? For part B, if you want to find the largest value of x, you don't take from the first quadrant, you take from the fourth quadrant instead. Right, you take from the fourth quadrant, which is 2 pi minus alpha. And then how many rounds must you add? You add actually only 1 round. Okay, if you take 2 pi minus 0.9553 plus 2 pi, you realize that the answer you get will be less than 12 radians. Okay, and then you divide by 3. So the largest value will be 3.87. So that means you can have other values. You can have 3.5, 3.2, example 2.6 or whatever. But the largest one will be 3.87 for your angle x to be less than 4. Okay, so this question is tricky, right? So try to watch the video a few times. All right, let's look at another question. So solving trigo equations. Now you realize that there's a variations of different type of questions that you'll be faced with, like solving trigo equations just having one single ratio, could be just in terms of sine, cosine, or tangent. And sometimes you have to use the trigo identity. Sometimes you have to use the double angle addition formula. All these have been already dealt with in the earlier videos. So if you're not too familiar with all this, so please revisit the earlier videos. Okay, on double angles, using the double angle formula, using the addition formula, using the trigo identities. Okay, so if you look at part 1, right, part 1, please do not cancel cosine x, because if you cancel cosine x, you're actually missing out one set of answer. So the best way to do this is just to bring everything to the left-hand side and factorize the common factor. Right, so in this case here, the common factor is cosine x, so factorize it. Okay, then you apply the zero product rule. So cosine x equals to 0, or tan sine x minus 1 equals to 0. Right, so the next thing is that if you were to remember, we keep having to find alpha. Always remember alpha is in the cube angle. You must try to remember a cube angle, so you always cosine inverse a positive value. But here it's 0. 0 is not a positive value, it's an integer, so cosine inverse 0 gives us 90 degrees. Then that is the first concept, finding alpha. Second concept is your ASTC. So for cosine to be positive, you'll come from the first and the fourth quadrant. So first quadrant is just alpha itself, 90 degrees. Fourth quadrant will be 360 minus alpha, which is 360 minus 90, give you 270 degrees. So that will be the answer for the first set when cosine x equals to 0. So how about tan sine x minus 1 equals to 0? Yes, you have to find sine x, which is 1 over 10, then go on to find alpha, which is 5.739 degrees. So for sine to be positive, ASTC again will come from the first and the second quadrant. First quadrant is just alpha equals to x, which is 5.74. Second quadrant is 180 degrees minus alpha. So 180 minus 5.739 gives you 174.3 degrees. So again, these concepts have been revised already in the earlier video. So if I'm not too sure, you must go and revise the earlier video. Watch the earlier videos. All right, so how about part 2? Okay, part 2, if you look at it very carefully, all right, if you have remember all your trigo formula well, then you know that that one you have to use trigo identities, right? So which identities that come to your mind? Yes, we use 1 plus tangent square x equals to secant square x, right? So you replace the secant squared y, replace this guy here with 1 plus tangent squared y. All right, so you end up with a quadratic equation involving tangent y, right? And then you factorize it. Okay, and then the story continue, the same story, right? Make tangent y the subject, which is negative half. Find your alpha. Alpha is always tangent inverse positive value, so positive tangent inverse half give you 26.57. But because we are finding the answer for trigo ratio to be a negative, so under ASTC, you come from second and the fourth quadrant. All right, so first answer come from the second quadrant, which is 180 minus alpha. Fourth quadrant will be 360 minus 2 alpha. Okay, so that settle our tangent y equals to negative half. How about tangent y minus 3 equals to 0? Yes, continue the story. Tangent y equals to 3. So alpha will be tangent inverse 3. Okay, tangent to be positive. Why positive? Because 3 is a positive value. Tangent y equals to 3, so 3 is a positive value. So for tangent to be positive, which quadrant does it come from? First and third. Yes, first and third. So the first one will just be alpha itself, and then the third will be 180 degrees plus alpha. So gives you 251.6 degrees. All right, so part 3. Part 3 is a bit tricky. Why a bit tricky? Because secant x, what does secant x remind you of? Yes, the reciprocal ratio. Secant x is actually equals to 1 over cosine x. Okay, look at the third letter, which is the letter C. C, it's the first letter of the trigo function cosine. So 1 over cosine x. All right, so you convert it. Yes, to 1 over cos bracket half z plus 105 degrees. Okay, this is something I need to remind you, okay? Please do not write it as 1 over cosine and then bracket. Okay, it does not make sense. All right. Your angle must be beside your cosine, not beside 1 over cosine. So this is a big no. Okay? Right. So be very careful how you write it. It's 1 over cosine and bracket half z plus 107 degrees, close bracket equals to negative 2. All right, write negative 2 as negative 2 over 1 so that you can just flip on both sides. Okay, flip the left, flip the right. Okay, new range. All right, because you're dealing with half z plus 107, so you need to find the new range. Okay, this one, there's an error here. This one is 107 degrees less than half x plus 107 degrees. I forgot to add that. Just a minor one. Okay, so likewise, what do we do? Find alpha. Okay, alpha will be cosine inverse half, which is 60 degrees. And then because we're talking about a negative answer, so cosine negative will come from the second or the third quadrant. So I already indicated there for you. Second quadrant, which is just 180 minus alpha. Third quadrant is 180 plus alpha. Okay, and then go on to find the values for z, which is 26 degrees. Oh, exactly. It's not approximate sign, it's exactly equals to 26. Because 180 minus 60 plus, 180 minus 60 minus 107 times 2 will give you exactly 26. 180 plus 60 minus 107 times 2 will give you exactly 266. Okay, so this is how you solved all the 3 questions here. 3 parts of the questions for question 44. All right, so if you look at part 1, okay, again, the format of the questions changes. It's not so straightforward, but the concept remain the same. What does it mean by concept remain the same? We just make tangent bracket x minus 30 degrees on the left hand side. Okay, so the next step, what is the next concept? Find alpha. Yes, I keep saying alpha. Maybe you should name your dog or your cat alpha. So alpha will be just tangent inverse tangent 50. That gives you 50 degrees. Okay, so the next thing is that tangent 50, it's a cube angle, positive value. It will be a positive value. So for tangent to be positive, which quadrant it come from? Yes, ASTC, ASTC. So it will come from first and the third quadrant. Okay, so first quadrant is just alpha itself, which is 50. Third quadrant is 180 plus alpha. So from there, you can just find your x to be 80 degrees or 260 degrees. Oh, and I forgot the unit. All right, the little circle must be there. Okay, so that's part one, relatively easy. Part two, it's a bit similar to what we have done earlier on, except that you have to convert tangent y, okay, tangent y into what? Tangent is the third, is tangent y, it's the equals to sine y over cos y. It's the third party of sine and cosine. All right, so tangent y can be written as sine y over cos y. Okay, so we need to rewrite tangent y as sine y over cos y. Then you multiply every term by cos y. So that gives you 3 sine y cos y plus sine y equals to 0. Because 0 times cos y gives you 0. Okay, can you see a common factor there, which is sine y, factorize it? All right, so after these steps, the story repeats. Story repeats. What does it mean by story repeats? It means sine y can be equals to 0, or okay, we do one at a time. So if sine y equals to 0, the next step is to do what? Find alpha. So sine inverse 0 is 0 degrees. So for sine to be positive can be first, second. But how do I get 360? You actually add one more round to your 0. 0 plus one more round. One round is 360 degrees, so 0 plus 360 give you 360. So these are the three possible answers. Okay, so if you were to realize sometimes I include 0 degrees and 360, but sometimes I don't. So when do you know when to include and when not to include? Of course, you have to look at the question lah. In this case here, can you see? You're supposed to find the angles from 0 to 360 degrees inclusive. Inclusive means you must include 0 degrees and 360 degrees. That's what it means by inclusive. Okay, if it's exclusive means you don't include. Inclusive means include. Exclusive means you don't include. Okay, so that is how you solve for sine y equals to 0. So the other one, yes, so 3 cos y will be equals to -1. So cos y will be -1/3, find alpha. So for cosine y to be negative, which are the two possible quadrants? Yes, second and third. All right, so that's how we get the answer. So how about the part 3? Okay, part 3, there's a star there. What does a star mean? Star means it's a bit tricky lah. Okay, but it's not exactly that difficult also, right? It's not. You have to use your trigo identity to replace your cosine squared z with 1 minus sine squared z. Then you will have a equations. But you can still factorize it as per normal, even though it's the power of 4. You can still use here, this method here. If you were to recall, you learned this one. Right, here will be your sine to the power of 4z. Oh, there's a 2 there, sorry. Here will be 3. This guy will be -7 sine square z. Right, so how do you get sine to the power of 4z? Obviously, you need to have sine squared z multiplied with another 2 sine square z lah. Sine square z times 2 sine square z will give you 2 sine to the power of 4z, right? And what are the factors of 3? Can be -3 and 1. Oh, -3 and -1. It must be -3 and -1 because I need a positive 3 here. So you need -3 times -1 to get the 3. And then here will be -6 sine square z. Here will be negative sine square z. So that how you get your -7 sine square z here. Okay, so you can still factorize it. Okay, it's not difficult. Not very difficult. Okay, but it can be done. All right, so you will have 2 sine square z equals to 1. So sine square z equals to half. So sine z can be plus minus square root half. So this plus minus will tell you that, okay, the answer can come from positive, which is first and second, can also come from the negative, which is third and fourth. So in other words, your answer will comprises of first, second, third, fourth. All right, then for the other guy, sine square z equals to 3, sine z will be plus minus square root 3. Square root 3 is 1.732, blah, blah, blah. So anything that's more than the maximum value for sine z is 1, minimum value is negative 1. So plus minus 1.732 will be out of the range. That's why it's not applicable. All right, let's look at another questions involving solving trigo equations. Right, I hope after trying out so many questions on solving trigo equations, you'll become an expert in it. And I've been trying to speak rather fast. So I try to slow down a bit because I think the concepts involved are pretty similar, just that the format of the questions are different. Right, so when it comes to the last part, like finding alpha, finding which quadrant it is, I'll tend to speak a little bit faster. Okay, right, so part 1. All right, what's the next thing we do? Yes, find the new range, right? So in this case here, you're supposed to solve giving all solutions between 0 degrees and 360 degrees. So when you say between 0 degrees and 360 degrees, it means it does not include 0 and 360. Okay, anything between it, that means more than 0, less than 360. This is what it means. Okay, so find new range. So can you see what, the same kind of things that we've been doing over and over again? Find new range, find alpha, find the quadrants is this in, right? So tangent inverse 145 degrees. All right, so we need to go to find the answers all the way to 1080. That's how many rounds? That's 3 rounds, I think. Right, so first answer will be from the first. So for tangent to be positive is first and third quadrant. Okay, so first answer will be from the first quadrant. Second answer will be from the third quadrant. And because we're talking about 1080, so your first answer at 1 round, and then at another 1 more round. So that means your first answer is 45, right? At 1 round is plus 360, right? At the second round means plus 720. Okay, so likewise for your answer from the third quadrant. Answer from the third quadrant, likewise. First answer is like that, right? Then you add 1 more round, which is 360, right? Then you have to go another 1 more round, which is plus 720. So finally, you divide all your answers by 3. That will give you 1575, 135, 195, 255, and 315. Okay, so many answers for tangent 3x equals to 1. So the concept is the same, right? So sometimes so if they give you tangent 4x equals to 1, then how many sets of answer will you get? 4 times 2, 8. 8 answers or 8 sets of answer. Also depending on the range you want to give, you're required lah. If it's between 0 degrees and 360 degrees, then tangent 4x equals to 1 will give you 8 sets of answer lor. Okay, and then how about part 2? Right, part 2, that's very familiar, right? But now you should know already. What formula do we use? Yes, we use the trigo identity. Okay, right. So we're going to replace cosine squared y with 1 minus sine squared y. Then you end up having a quadratic equation involving with sine x. And what do we do? Factorize it. Then you apply the zero product rule. So sine y equals to negative 1/3. So find alpha, which is sine inverse 1/3. And then sine negative. Okay, this guy is negative. So negative ASTC. For sine to be negative will come from third and fourth. Okay, so as indicated there for you, third and fourth. Right. But how about the other guy? How about sine y plus 2 equals to 0? Right, that's not applicable because the maximum value for sine y, the range for sine y will be between negative 1 to 1. So anything more than that or less than that is not applicable. More than that? Yeah, more than 1. Or less than negative 1 is not applicable. Alright, don't fall asleep. We're coming to the end very soon. Let's look at questions 47. Okay, same concept but a different kind of questioning. Right, in this case here, you're supposed to solve for cotangent bracket 2y minus 65 degrees equals to negative 2. So cotangent, what is cotangent? Can you recall what cotangent x is actually the reciprocal ratio, right? Which is equals to, cotangent x is equals to 1 over tangent x. And then there's a reminder for you. This one I've already reminded you in the earlier slides when we was dealing with secant x. Here I'm going to remind you again. Please do not write it. This is the wrong format. This is the wrong format. Okay, the angle must be strictly beside your tangent, not beside 1 over tangent. Okay, this does not make sense at all. It's wrong. Can you see how many crosses that I've drawn underneath it? It does not make sense. Right, so what is the correct way of writing it? Yes, the correct way is like that. 1 over. Okay, then tangent bracket 2y minus 65 degrees. So write negative 2 as negative 2 over 1, and you just do a flip. So you get tangent bracket 2y minus 65 degrees is equals to negative half. So what's the next step we do? Yes, of course, you have to find your new range. And if you look at the new range, this question is tricky. Why is it tricky? Because it involves angle in a clockwise direction, also involve, this is the angle taken in the clockwise direction. It also involves angle taken in the anti-clockwise direction. So it's tricky. Right, so before we do the tricky part, we still have to find alpha. So alpha is tangent inverse half, which is 26.57 degrees. Okay, so let's deal with angle that is taken in the anti-clockwise direction first. So for cosine to be negative, it will come from second and the fourth. That's how I explain. That's how I get my answer here. Can you see? Second and the fourth. Second will be 180 minus alpha. Fourth will be 360 minus alpha. Then, because it involved this guy here, the tricky guy, so I also need to consider the negative angle, right? The angle in the clockwise direction. Alright, so for tangent to be negative, okay, you see, this part here, this quadrant is where tangent is negative. So therefore, my angle x is equals to negative alpha. Can you see? Okay, that's why I have a negative here. Let me explain to you. It's because we are talking about angle measure in the clockwise direction. Why you need to consider that? Because of this range this troublesome range. You see, anytime we have a range that is given, include negative and positive, that is where your headaches will come. Alright, but if you learn the skill right, you don't need to have any headaches. Okay, you don't need to eat Panadol. Alright, just learn the skill properly. Okay, so here in the fourth quadrant, your tangent will be negative in the fourth quadrant. Right, so it's equals to negative alpha. Alright, then from there, okay, you can just go on to find your values of y. Okay, so 4 answers. Right, so that is part A. Then how about part B? Right, let's do part B. So how do we do part B? So if you look at the questions carefully, right, what does it remind you of? Something squared minus something squared. So what is something squared minus something squared? A squared minus B squared. What does it remind you of? Yes, you can factorize it into A minus B and A plus B, right? So this is one of the algebraic identity, a very popular one and very useful one also. So I'm going to do that. So before I do that, I can rewrite 9 sine squared z as bracket 3 sine z to the power of 2. Because 3 sine z times 3 sine z will gives you 9 sine squared z. Okay? Alright, so from there you can factorize it into 3 sine z minus tangent z, 3 sine z plus tangent z. So you apply your zero product rule, and then rewrite tangent z as sine z over cos z, do a cross multiply. Okay, bring everything to the left hand side. So it's similar, this part here, this one here, if you recall, is similar to the earlier slides. I think one of the 2 questions we've done earlier, similar concept where you factorize a common factor. So here a common factor will be sine z. Okay, then you apply your zero product rule, sine z equals to 0. So find alpha, okay, our dear friend alpha, sine inverse 0. So it can be 0 degrees, 180 or 360. Okay, why do you include 0 and 360? Because look at the dear question. The dear question says so. Okay, 0 degree, 360 inclusive. We must include 0 and 360. Alright, that's the reason. Then for the other one, yes, go on to find your alpha. Tangent to be positive will come from the first and the fourth quadrant. Okay, so the tricky part is this one. This is the tricky part here, lor. Well, you need to apply your algebraic identity, yeah, your a squared minus b squared to factorize it, and then rewrite tangent z as sine z over cos z. Okay, please don't fall asleep. We're coming to the second last slide. All right, so this one is not difficult. Why not difficult? Because cotangent x is actually just cos x over sine x. Yeah, so you just replace your cotangent x with cos x over sine x. Do a cross multiply, simplify it. Use your trigo identity. Right, sine square x plus cos square x equals to 1. Replace your cos square x as 1 minus sine square x. Okay, and then you do some simple algebraic manipulation and you get the equations you asked for here. So in this case here, your A is 6, your B is 13, and then the values of C is negative 5. Okay, so this first part is easily done. Second part also is not difficult, just to solve it. Right, so you factorize it. Okay, we do the easy one first because the easy one means sine x equals to negative 5 over 2 and that's not applicable. Right, remember the range for sine x is between negative 1 to 1. So anything that is less than a negative 1 is not applicable. Okay, the other one. Alright, sine x, alright, equals to 1/3. As usual, find alpha, sine inverse 1/3. So for sine to be positive, it comes from which quadrant? First and the second quadrant. Okay, so we have done enough questions on solving trigo equations that I really hope that you can be able to solve, have the confidence to solve any questions that you may encounter in the future, be it in your test or in, or your friend or your little brother or sister asks you how to do this question, you should be able to advise them as accordingly. Okay, if you're very tired and about to fall asleep, all right, you can fall asleep after I've listened to my explanation on this last question that is applying the concepts of R formula. Okay, right. So if you look at the questions here, you have a farmer and farmer wants to fence part of the land. So want to put a fence around the land, maybe to prevent from other, other creatures, entering the land to eat the grass or to eat his animals or whatever. I'm not too sure lah. Okay, so what happened is that the fence will be put around A, B, C, D, A plus B, D. So read question very carefully. So basically, I just highlighted for you all the regions that you're supposed to fence it up. Okay, A, B, B, C, C, D, D, A, and B, D. Right. So we're talking about right angle triangle. Okay, where are the right angle triangle? Here lah. The right angle triangles are here. Aiyo, okay, these are the right angle triangle. So if you're talking about right angle triangle, what are the concepts you can use? Yes, we can apply Torcaso, okay? So from there, I can let sine theta equals to BD over AT. And I can find BD to be AT sine theta. Go on to find also AD using cosine theta. And after you found the values for BD and AD, then the rest is simple already. Just add up all the three sides. Not three, sorry, 1, 2, 3, 4, 1, 2, 3, 4, 5 sides. Add up all the 5 sides. And you get 160 plus 80 sine theta plus 160 cosine theta. Okay, so these 3 marks can be earned quite easily. Alright, part 2. Right, so we're going to express 80 sine theta plus 160 cos theta using the R formula. So equals to R sine bracket theta plus alpha. So right now the values of A and B. A and B are positive value, okay? A and B are positive value. Let me repeat, A and B are positive value. So A is 80, B is 160. So to find R is square root A squared plus B squared, blah, 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 blah. You get 178.89. Why I need to have 178.89? Because I need that for some intermediate working. But my final answer is to treat significant figure, which is 179. Find alpha, which is tangent inverse b over a. Because your answer is supposed to be expressed in radian. How do you know it's supposed to be radian? Yes, because look at the diagram. Theta, radian, theta, radian. So that gives you an idea that your answer must be in radian. So for radian must be three significant figure, 1.11 for the final answer. But I'm having 1.107 because I need it to solve part 3. Okay, so that is my answer for part 2. Then for part 3, so for part 3, you're told that the farmer uses exactly 310 meters of fencing. So basically, you just let this guy here. Okay, you've already found here, right? L is the formula to find parameter. So you just let it equals to 310. Okay, and then make sine ratio the subject equals to this. Find alpha. Okay, and then right. So this last question is for you to think about it, okay? Because I've already explained so much to you, right? You must do some thinking on your own. So the questions that I want to ask you is that we know for sine to be positive, it will come from first and second, right? Sine ASTC. For sine to be positive, come from first and second. But why is it that I only choose the second quadrant? Why is it that I never choose the first quadrant? Okay, can you think about it? I won't tell you the answer. All right, so that's the end of all the slides. Okay, thank you very much for your patience. Okay, and please work hard for your end of year exam.